Hey, welcome to Math Lesson 7.6. You'll need orange and green. Today we're talking about coordinate graphing. Make sure to get the date in the green box. This is going to take some time to set up your journal, so go ahead and push pause on the video until it looks like this. So you should have written that we can use ordered pairs found in tables to graph points on the coordinate plane. Put that in a green cloud. Underlining ordered pairs is super important because it's making you remember that those are important and tell an exact location. Ordered pairs, with the first orange arrow, says, ordered pairs are your x and y coordinates. The second arrow says, complete tables by figuring out relationships and number patterns, what we've studied in the past. And the third arrow says, plot points and connect them. That's interesting. That's a little bit different. We're not just going to be putting the points on the graph. We're going to put them and then try to connect them, kind of like making a line through the points. So that's going to be interesting today. As much fun as that was to get all that written in your journal, we're now going to turn to our workbook. Leave all this empty space because we're going to be gluing things in there. The page number that you need in your workbook is page 299. It has a blue bird at the top, and it says Unit 7, Lesson 6, page 299. While you're getting that out, or if you need extra time, you can always push pause on the video. But I'm just going to put the journal to the side and leave out the colors and the pencil. All right. It says, generate and graph ordered pairs. I guess we should get our name and number at the top of this since it says name. This is what we were talking about in our journal. We have tables that tell us the rules or tell us what's happening, that we have to figure out the tables. Then we have to take the tables and find the corresponding pairs. So we circle those. And we write them as our x and y coordinates. So put your finger on the add 4 table. And look, they put in 1. They followed the rule. They added 5 and they added 4 and they got out 5. So you put in the number, you get out a different number. So at the top of this little table, we're going to write in, out. Too bad we can't just go to in and out, but this is an in and out function table. I put a number in, I do something to the number, and I get a different number out. I might get the exact same number out depending on what the rule was. If the rule was add 0, then when I put in a number, I would get out the same number. So you just have to figure out what the rule is. Sometimes they'll tell us the rule, and sometimes they won't. This is the rule. The thing in blue is the rule. Please write that on your paper. Think about these numbers and what they mean, and see if you can connect how they formed this corresponding pair into an ordered pair. Oh, this was the x number, and the 5 is the y number. So the x's are on the left in this case. The y's are on the right. That's how you can tell over here as well. So here's what the paper says. It says numerical patterns can be written horizontally or vertically. This is horizontal because it goes left to right. Vertical is how tall something is. So these connections are going left to right. The add 4 table below shows a numerical pattern in the left column. Oh, look, going down. 1, 2, 3, 4, 5. That's a pattern. What would be the next number, everybody? 6, right? So the add 4 below shows a numerical pattern in the left column and the result of adding 4 in the right column. So if I'm going to add 4 to 2, I would get out 6. If I'm going to add 4 to 3, I would get out 7. And some of you are finding the pattern here. Sorry about that. Okay, so do you see the pattern on the left-hand column and the pattern on the right-hand column now? They all kind of follow an interesting pattern. But we're going to circle corresponding pairs. A corresponding pair, I'm going to use green. Corresponding pairs, in this case, are connected left to right because that was the rule. It was to take the number on the left and do something to it. So go ahead and circle all of the corresponding pairs in green. Now we take those corresponding pairs and we transition or transform them into ordered pairs. Okay, look at the example. 1, 5. The next one would be 2, 6. 3, 7. This is pretty easy. I mean, compared to some of the stuff we've done in 5th grade, this is pretty simple to move the numbers over. What if you switched the order of the numbers? Would that give you the same exact location? No. So it's really important that you keep the order of the numbers. Okay. Did we, number 1, complete the add 4 table? Yes or no, everybody? Yes. So put a little check mark there. Yep. Did we complete the X and Y table to show the ordered pairs? Yes. Check mark. Each ordered pair represents a point in the coordinate plane. Graph and connect the points. We have not done that yet. So let's go to graph and then we'll connect. To graph the points, you just go like this. You don't have to label them anything. They didn't put a letter A or anything by it, so you just get to put a point. A point needs to be a pretty decent size dot colored in, but don't have it be massive. It really needs to be in a specific point. So ready? 1, 5. I start at the origin. Always start at the origin, 0, 0. And I move over 1, up 5. You first walk to the elevator, then it takes you up. And I plot a point where that belongs. Over 1, up 5. Next one is over 2, up 6. Where do I begin? At the origin. You always come back to the origin. Over 2, up 6. Why don't you go ahead and finish plotting all of these points? They follow a pattern. So you should be able to figure it out after plotting about 2 or 3 of them. You should be like, oh, I can see what's happening here. 4, 8, and 5, 9. True or false, everybody? If I connect all these points, it will be a straight line. True or false? True. That's correct. Now, when I, a human, draw the line, it might not be perfectly straight, but because these have all landed in corners right here, it's going to end up being a straight line. So the easiest way to connect points, it doesn't say to extend the line. Sometimes it does. It only says to connect the points. So I just go from the first dot through all the dots to the last dot. Watch. The easiest way to do that is to use your paper and to have all of the dots line up there. Some people just go, well, no, I'm just going to go halfway through all of the squares and make a diagonal. That's fine too. So whatever way you want to do that. So we're going to put 2 check marks on number 3. We graphed the points, so check, and we connected the points, check. Sometimes it'll ask you to extend the line. And what that means is you know based on this pattern that it's going to continue that direction. You also could maybe see that a number could have come before it. It could have hit it right here. So that's what extending the line means. It means to show I know what the growth is, the pattern, and just I would do something like this. Don't do it because I'm going to erase it. But I would extend the line like this with an arrow, showing that it would keep going. It would just keep going. Okay, but they didn't ask us to extend the line. I'm just telling you it comes up later, so just be prepared for that. Okay, let's move on. See how easy that is? Now, the whole next section goes together. Suppose a shrub, love that word, shrub. Suppose a shrub grows at the rate shown in the table below. Use the table to complete exercises 4 and 5. Wow, they did all the table for us. If the shrub is 0 years old, it hasn't grown at all. That makes sense, obviously. Next one. When the shrub was 1 year of age, it was 1 foot tall. So, how much do you think it grows in a year? Let's look at this. When it was 2 years of age, it was 2 feet in height or tall. So if in 1 year it was 1 foot, and in 2 years it was 2 feet, in 3 years it was 3 feet, in 4 years it was 4 feet. It's growing a foot every year. Do you understand that connection? Okay. Well, it says Number 4 says, write 5 ordered pairs that the data represent. Will you take your orange this time? The ordered pairs are still horizontal. If I have not planted the shrub, it's not going to grow. 0, 0. That makes sense. If I plant a shrub and I wait for a year, it should be 1 foot tall. If I planted it and let it grow for 2 years, it should be 2 feet tall. These are the ordered pairs, going left to right. But it wants us to write them, not just circle. I like to do the circling to connect what is happening. And then the ordered pairs have to have parentheses with commas. And because you're doing 5, you might as well set up 5 sets of those right now. Oh, I only put 4 on the line. Okay, there's 5. You need to have a comma in between. That is an ordered pair. The first one is so interesting. Does anyone know what the first ordered pair is? So interesting. What is the first ordered pair? Think it through for a minute. What is the first ordered pair in this particular table? The first ordered pair, number 6. I actually meant number 7.
The first ordered pair is 0, 0.
That is correct. How interesting. What else do you know about that, number 7? What is 0, 0?
It is the origin.
That's correct. You can go get a group point and a stamp. Nice job. Okay, so the next ordered pair is 1, 1. 2, 2. You guys get it. Keep going. I completed number 4. It did not ask me to do any graphing yet. So you really have to take these problems one step at a time, because sometimes if you go too fast, you skip things. So let's just look at number 4. Did we do what it asked on number 4? Yes. Number 5. Graph the ordered pairs and connect the points. Let us begin doing that. Okay? Graph the ordered pairs. 0, 0. What? There's a point right there on the origin. That is correct. That is actually very common. So don't panic by that. 0, 0, there can be a point right on the origin. The next point is 1, 1. Over 1, up 1. Oh, this is going to follow a pattern. Over 2, up 2. Over 3, up 3. And over 4, up 4. I graphed them. Check. Little baby check over here. I have not connected them yet. Does it ask me to extend the line? No, it does not. So I just connect them. This is a line segment that is going through multiple points on the graph. Okay. That looks pretty great. I connected them. Check. But that wasn't even the question for number 5. That was like, you have to do these things before you can answer the real question. So the question is, what does each axis of the graph represent? Well, I know this is the x-axis, but what is it? Like, it has to represent something from the information I was given. This could be, remember how we talked about these numbers being x and these numbers being y? Ah, so the x line represents whatever x was talking about. What was x talking about in this math table? X is talking about how old the shrub is, the age in years. So I would say the x-axis represents the age in years, because we're not talking about months or minutes or anything like that. The x-axis represents the age in years. So let's write that. Let's actually label the axis. That is going to be something you have to do today, labeling the axis. So you would write it like this. Age. I literally take it right from the table. What it says right here, age, parentheses, years. And I put it on the x-axis. I'm labeling the axis. You have to be able to do this on the test. You have to be able to label it. Then I look at what about the y-axis? What does the y-axis represent? And sometimes I get really confused until I look at the table. Well, what were all of the y coordinates telling me? How tall it was, the height in feet. So the y-axis represents the height in feet. So this makes sense. The longer the shrub is alive, think about what this means. The longer it is alive, let's say it makes it to be 10 years old. How tall can it be expected to be if it's 10 years old? That's what this is making your brain do. Do you know how tall? I just jumped to a huge number. How tall do you think that shrub's going to be if it gets all the way to 10 years old? What is the height going to be at? Okay, wow, that's a lot of people who know. Thank you. Number 18, what would the height be at?
10.
That is
what it's expected.
Nice, I love that. Get a group point. The 10 is what it's expected to be because of the growth rate. This is called the growth rate. So I need to label the y-axis. It's the height. And quite frequently, this is how they do it. They will turn it and write it like this. Have you ever seen that before? Nod your head if you have on a graph where it's labeled and you have to turn the paper. Yeah, that's pretty normal. One thing we're missing for this, and it hasn't asked us to do this, but I know that your assignment and the quiz and the test do ask this. They will ask you sometimes to give this graph, this plane, coordinate plane, a title. Like, what are we looking at? What do you think might be an interesting title for this particular graph? There is a right answer here. I would use the information they have given you. Look at the paper for just a second. We have used the age in years, the height in feet. What would be an overall good title for this graph? What do you think an overall good title would be? Number 8?
Growth of a shrub, because it says it right up there.
I love it. He took it right from here. That's correct. Growth of a shrub. He took the title of the table and made it be the title of the plane, the coordinate plane. That is genius. We're going to do it right now. Growth of a shrub. Then I don't have to be guessing a title. I don't have to be, did I spell it right? It's just, I took the information over. So this is pretty cool. You can look at information just on a table and understand what's going on, or I could completely hide the table from you. And now as a 5th grader, you need to be able to look at a coordinate graph and understand what's going on, just like number 18 did. He said, well, if it's 10 years old, it would be expected to be 10 feet tall because that's the projected growth rate. That's what's happening. And here's another way to explain it. Every year that we get older with a shrub, it gets a foot taller. What would be expected to be if it lived to be 94 years old? It would be expected to be 94 feet tall. Okay, turn the page. See? Oh, more tables, more fun. I love this stuff so much. Oh, I would so much rather be doing this than long division. I love it. Look at this. We have a title, water leak. They have labeled the x-axis and the y-axis. Time in minutes. Ooh, I see that. Right here. That means these are my x coordinates. See? I'm making connections. I see amount of water right here. So that is my y coordinates. All right. My corresponding pairs are not left and right this time. Look at what they are. They're top and bottom. So before I even do this, I'm just going to show you with the orange. These are corresponding pairs now. Not left and right, top and bottom. And how did Ms. Fisher figure that out? I looked at the x and went, oh, that's the x line. This is the y line. And coordinating or corresponding pairs have an x and a y. So that's how you have to go top then bottom, top then bottom, top then bottom. All right, let's just read what it says. Real world problems. Every 20 minutes, a dripping faucet. So I have had one of these in my house before where even if you turn the water off, it's dripping. And it drips at a constant rate. Okay. Every 20 minutes, a dripping faucet leaks 10 milliliters of water. Complete the table to show the amount of water that will leak in 0 minutes, Okay, if the water is not leaking at all, how much has it leaked? 0. Okay, good. I'm glad you know that one. Anyway, how many milliliters will it have leaked in 40 minutes and 60 minutes? So you have to think about it. If it was going for 20 minutes, the amount of water leaked was 10. What is happening between the top number and the bottom number? You can't just say minus 10, because look, if I did 0 minus 10, it would not be 0. It would be negative 10. That's not the rule. Minus 10 is not the rule. So something else has to be happening. I put in 20 and I got out 10. So it can't be minus 10. What's the other relationship? It's divided by 2. What if I take 0 and divide it by 2? What do I get? 0. So that rule worked. 20 divided by 2 is 10. 40 divided by 2 is 20. 60 divided by 2 is 30. Okay. That's pretty interesting, huh? You can't just jump to 1 and go, oh, the relationship is minus 10. It has to work for 2 of them. If it doesn't work for 2 of them, it cannot be the rule. Are we clear? Okay. Okay, great. We've completed the table. Check. Number 7. Write the X, Y, or the ordered pairs that the data represent. Oh, they're combining a lot of things here. Then graph and connect the points and extend the line. Number 7 just did 4 things. So you will miss a ton of points if you don't follow all 4 things. Let's do this. Write the ordered pairs. Okay. 0, 0. 20, 10. 40, 20. And 60, 30. All I did was write the ordered pairs. Check. Now graph and connect the points. Okay, 0, 0. Ooh, look how interesting this plane is. They're not going up by 1. Every single line is going up by 10. This is super important to understand. You can't just put whatever numbers you want. You can't be like, okay, the first line is 1, and then I want it to be like 30, and then I want it to be 40. It has to go up in a constant rate. So if I went up by 20 from here to here, I have to go up by 20 more from here to here. I can't just do whatever I want. It has to be equal amounts. So look, every single time, what did my X line do? It went up by 10 every single time. 0 plus 10 is 10. 10 plus 10 is 20. Those are all equivalent rates. What about going up? 0 to 10. That was adding 10. 10 to 20. That was adding 10. So yay, it's doing it. It is following a constant rate. Yay, that's good to know. All right, so the first one I graph, do I go over 20 and count 20 lines? No, I find the 20. Okay, there's the 20. And up to the 10. Okay, right there. Interesting, huh? It's not always about counting, it's about finding the number. Find 40, go over 40, up to 20. Find 60, start at 0. Find 30. Oh, I can see the pattern here. This is not as steep of a line, but it is still a straight line. So you're going to connect the points. Okay, connect the points. Then it says, and extend the line. So you just kind of follow, like pretend that you would know where it would be if it went to 80. Like, okay, if I went to 80, it would be at that point. So it's going to kind of go like this. Or you can just like pretend to draw that line again and keep that same steepness. That's kind of what I do usually. I just start back at the beginning and I go, okay, just draw a line, Fisher. Draw a line. And put an arrow on the end of it. Putting the arrow on the end of it lets it be extended. Hi, Mrs. Carver. Do you, instead of calling a name, will you call a number?
How about 15?
Number 15 here today. Yep, thank you so much. Okay, so I've extended the line. It's not perfect. I can tell on mine that it's kind of not as straight as it should be. and that's okay, but you can't be super far off. It can't be like here and then boop, up here. It needs to look like you've tried to follow the straight line. Okay, we extended the line. Great. I love questions like number 8. This is my favorite part about doing this stuff. It's like being an investigator or a detective. What amount of water would you expect to leak in 90 minutes? Well, that was perfect. That Fisher put her arrow right there at 90 minutes. I didn't mean to. Maybe yours isn't right there, but you just go, okay, well, if I was to follow this projection or this rate, where would it be at 90? Some people like to look at the graph. Other people like to go, no, I'm just going back to a table. That's sometimes easier for me because I like numbers, not pictures. Some people go, oh, 90, it would be at... But then you might be guessing and be like, wait, would it really be clear up here? Was mine right, or would it be here? I'm going to use the table because I'm not sure. So I go, okay, let's go up here to the table, everybody. If I put in 90, if it was going for 90 minutes, how much water would have leaked? You just follow the rule. What was the rule? Divide by 2, divide by 2, divide by 2. 90 divided by 2 is 45. So it should have been at 45. If I were to go back to this graph, there's 90. Ooh, Fisher's arrow right there was on the 50. Was my line perfectly straight? No. Should have probably been about right there. That's why the table was super helpful. So I wouldn't just go straight to the graph and go, oh, well, I'm just going to guess. I think it would be, don't ever guess with stuff like this. Go back to the table and just plug the numbers in. So it says, what amount of water would you expect to leak? 45 milliliters of water would be expected to leak in 90 minutes. It says explain your answer. So all I say is I used 90 in the table. I'm just explaining what I did. And got out 45 by following the rule. Or you could say by following the rate. Whichever one you want to say. The rate is you're dividing by 2 or for every 10 minutes. Anyway, okay. We are going to take a break right there and we'll catch you in the next video.